An army of 1.5 million iguanas is quietly destroying a billion-dollar infrastructure system in Florida. They dig through dams, hollow out the foundations beneath luxury residential areas, and cause the strongest seawalls to suffer serious structural decline. Authorities have tried everything from cash rewards and thermal drones to high-voltage electric fences, but all of it has failed. This population continues to grow exponentially, beyond control. But suddenly, in the worst hotspots, millions of iguanas began disappearing without a trace. Every cage trap was empty, and control tools suddenly became useless as a hidden force appeared and took over management of the area for humans at astonishing speed. Many people thought this was a mysterious population decline, but the reality was even more surprising. Who is the anonymous hunter silently removing this invasive species in the dark? And what made Florida's strongest infrastructure network surrender to an exotic pet species? The South Florida Water Management District currently has to maintain more than 3,300 kilometers of canals, a vital flood control system worth billions of US dollars, protecting the lives and property of more than 9 million residents. This system is being destroyed from within. More than 1 million green iguanas, which can reach 1.8 meters in length and weigh more than 6.8 kilograms, are turning this irrigation network into a material stress test site. They do not only strip native vegetation clean, their claws are biological drilling machines. Green iguanas dig complex burrow systems through canal banks, hollow out concrete foundations, and damage seawalls. Data from regional construction contractors show that, in the city of Boca Raton alone, shoreline infrastructure repair budgets have consumed hundreds of thousands of US dollars every quarter. Private property owners must pay an average of $4,000 to $6,000 US dollars for reinforced steel mesh systems and slippery barriers. All of them are breached after only a few months. Every physical defensive boundary built by humans has lost effectiveness against the mechanical destruction of this invasive species. The damage to seawalls is only the surface of the problem. The core of the crisis lies in a mathematical equation that humans cannot solve with traditional methods. The replication speed of green iguanas defeats every human tool and trap system. Biological data show that one adult female can lay from 50 to 70 eggs per clutch. Florida's ideal subtropical climate provides the temperature conditions for almost absolute hatching success, and in many cases, they can lay 2 clutches each year. Their population growth chart is an exponential curve with no sign of slowing down. Wildlife management agencies have completely removed protected status for this species. Large-scale control campaigns have been activated. Teams of licensed professional hunters use specialized equipment, smart cage traps, and night vision technology to remove iguanas year-round. Even record cold air events that push temperatures below 7 degrees Celsius, causing thousands of individuals to fall from trees in an immobilized state, could not change the overall picture. Humans remove tens of thousands of individuals each year, but hundreds of thousands of new ones hatch from beneath layers of soil and rock. Manual eradication only pushes them temporarily from one garden to another, completely ineffective against a population of millions spread across a wide area. Do you think the government paying a bounty for each captured iguana, a measure once applied to giant pythons, would make a difference? Or would it only create an unofficial breeding industry for profit? Share your thoughts in the comments below, because what happens next will prove that financial barriers never solve core ecological equations. Right when projection charts showed total loss of control, an abnormal signal appeared from the monitoring data system. Iguana numbers in several core areas suddenly dropped sharply. The cause came from another large-scale human intervention campaign that had taken place decades earlier. The overall picture changed not because of a new reproductive control chemical or an advanced automatic trapping technology. It was the direct result of one of the most expensive and complex ecological intervention projects in United States history, the reconstruction of the Everglades and South Florida biological corridors. At the most severe stage of decline, the Florida panther fell into endangered status, with its population dropping below 30 individuals because its habitat had been fragmented by a massive highway network. Great horned owls also nearly disappeared from urbanized areas as old-growth tree canopies were cut down in large numbers. To prevent the disappearance of these species, the government activated an infrastructure campaign with no precedent. To change the situation, the Florida Wildlife Corridor Act was passed, pouring more than $800 million into acquiring and protecting 18 million acres of connected land. To carry out this massive campaign, the United States Army Corps of Engineers was mobilized. A series of giant wildlife underpasses and ecological overpasses, worth tens of millions of U.S. dollars, were built aggressively. However, because Florida's groundwater level is too high, using deep tunnel boring machines was impossible. Instead, engineers applied a more forceful mechanical intervention method, driving thousands of pre-stressed concrete piles through the aquifer down to the hard limestone bedrock. Human infrastructure stepped back, lifting key highway sections such as I-75 into the air, directly returning divided wetlands to nature. Cougars from Texas were airlifted in to inject a new stream of genes and break the pattern of genetic decline. At the same time, private and public conservation funds bought back thousands of acres of suburban bufferland, strictly restoring tropical canopy strips that connected residential areas. This massive engineering and financial campaign provided the infrastructure hardware for two top predator populations to recover and expand their territory northward. The Florida panther population rose from 30 individuals to a safer level, while suburban forest strips were returned to the giant owl. When these hunters entered the green corridors along urban edges, they encountered a huge protein source their ancestors had never known: green iguanas. This collision activated a biological control machine that worked with astonishing smoothness. But what natural mechanism allowed it to bypass every monitoring technology? The effectiveness of this predator machine is determined by a physiological weakness in iguana biology. As cold-blooded creatures, they depend completely on environmental temperature. When the sun sets and temperatures drop, their metabolism stalls. When the surrounding temperature falls below 10 degrees Celsius, an automatic biological freezing mechanism is triggered. Their energy-processing enzymes and muscle contractions become completely paralyzed. Blood circulation slows, and the heart rate drops to only 2 to 3 beats per minute. The iguana's nerve transmission speed, muscle contraction ability, and reflexes are disabled by up to 90%. They become motionless targets lying on seawall edges and low tree branches. Facing them are warm-blooded hunting machines designed for silence and explosive power. While iguanas are locked in a state of physiological dormancy, Florida panthers activate the reflective layer at the back of the retina, amplifying the weakest rays of light from street lamps by up to 130 times to see through the night. Great horned owls possess talons that generate a crushing force of more than 300 psi, enough to quickly neutralize prey completely. The owl's asymmetrical hearing system allows it to map sound in three-dimensional space, precisely locating prey in total darkness. In addition, the owl's feather structure has microscopic serrated edges that break up turbulent air currents, eliminating low-frequency sound completely. From above, the great horned owl dives down like a silent shadow. From the ground, the Florida panther patrols along canal banks. The pressure of being trapped between an aerial predator and a ground predator leaves iguanas with zero resistance. The period from midnight to dawn becomes a biological consumption line, where the invasive species' temperature weakness is fully exploited. The traces left behind by these nighttime hunts have produced a large amount of undeniable empirical data, and when independent researchers entered the picture, remote sensing numbers exposed the entire truth. Scientists did not draw conclusions based on guesswork. High-resolution infrared camera traps set up along canal bank fences recorded an unprecedented decline in iguana frequency. Data from a GPS collar attached to one mature male Florida panther recorded 47 stopping coordinates that matched completely with the core area of the highest iguana density. 11 of those coordinates were located very close to the boundaries of canal-side residential areas. More than that, spatial analysis from independent organizations strengthened this phenomenon. Satellite data from the United States Geological Survey, combined with geographic information systems, revealed an astonishing truth. The heat map of canopy recovery from the Biological Corridor project matched 100% with the core decline zone of this invasive species. This key evidence confirmed that no government hunting team, even equipped with thermal scopes or specialized drones, could sweep an area with that level of precision. At another monitoring point, hidden cameras captured a great horned owl returning to the same tree branch for 11 consecutive nights. The feeding pattern of this raptor, separating the head and upper body while leaving the tail behind, appeared densely around the bases of large fig trees. The wide-scale result was the physical regeneration of infrastructure. Landscape maintenance workers reported hibiscus gardens sprouting again. Seawall sections were no longer being hollowed out. Daytime iguana sightings in areas where these two native predators were present dropped sharply. For the first time in decades of invasion, monitoring data confirmed a sustained downward trend in green iguanas without any direct intervention from professional eradication teams. Although the indicators are optimistic, this self-balancing system is still bound by strict mechanical limits. Hidden behind the perfect surface are potential risks that threaten to change the conservation gains. Early media reports often praised this story as a perfect conservation model. But in reality, when analyzing the system, experts warn of three extremely serious major loopholes. First is the urban heat island effect. Concrete blocks in city centers absorb and retain massive amounts of heat radiation at night. This creates thermal refuge zones, allowing iguanas to avoid paralysis and continue reproducing in the urban core. Second is the loss rate caused by traffic conflict. When Florida panthers are drawn deeper into suburban boundaries to hunt lizards, the risk of serious collisions with night trucks on secondary roads without underpasses rises sharply. Third is biological toxin accumulation. Urban iguanas often consume plants contaminated with herbicides or accidentally ingest pest control chemicals. When tens of thousands of iguanas are consumed, this biological toxin load transfers directly into the blood of panthers and owls, turning them into the next damaged links in the food chain they are cleaning up. The recovery of panthers and owls is not a complete solution for eliminating iguanas from all of South Florida. Their predation pressure is strictly limited by the physical boundaries of the ecosystem. Great horned owls need mature canopy strips to nest and hunt. Florida panthers require continuous habitat corridors to establish territory. In concrete urban cores, where these ecological elements are absent, iguanas continue to reproduce and maintain high densities. The complex problem in Florida opens a completely new perspective on how humans manage ecological risk at a macro scale. Decades of trying to control the problem locally, using chemicals or manual hunting, only addressed the surface symptoms. Real effectiveness appeared only when the government decided to intervene at the infrastructure layer, building underpasses, redirecting the gene pool, and reconnecting broken biological corridors. The future of control does not lie in creating more modern weapons, but in understanding and restoring the operating mechanisms of the system. When humans return enough space and tools to nature, the ecosystem will automatically re-establish its own balanced order, repairing mistakes that no amount of financial resources can solve alone. If you want to keep exploring the hidden downsides and objective truths behind large-scale intervention mega projects around the world, do not forget to hit like, share this video with the science-loving community, and subscribe to the channel. Your support is the motivation for us to keep deeply analyzing the systems that are quietly reshaping our planet in the next episodes.